Welcome to the Hudson Institute. I'm Bryan Clark. I'm a senior fellow at Hudson, as well as the director of the Center for Defense Concepts and Technology at Hudson. And we are pleased to have with us a great panel for a discussion about the future of autonomous warfare. It's focusing on uncrewed undersea systems. So with us is Admiral Rob Goucher, who is the commander of U.S. submarine forces, and previously has been the commander of Submarine Group 9, as well as the director for the Maritime Operations Center at the Commander of U.S. Pacific Fleet's headquarters. With us also is Dwayne Fotheringham from Huntington Ingalls Industries, now known as HII, where he is the president of Uncrewed Systems, as well as Matt Britton, who's the director of C5ISR hardware at HII Mission Technologies. Gentlemen, thank you for being here today, and we're looking forward to this conversation. So I want to start out, we want to talk a lot today about the recent progress in developing submarine-launched uncrewed undersea systems and the role they might play in the future of warfare, and about UUVs more broadly and how uncrewed systems might really be a complement to our submarine force and its traditional missions. So Admiral Goucher, what are some of the, what's some of the progress that we've made in terms of developing, fielding, testing submarine-launched uncrewed systems, and what role do you think they're going to play in future undersea operations?
Yeah, thanks for that question, Brian, and thanks for including me in the panel. I like to joke that I keep trying to get signed up for one of these, innovation panels, whether it's unmanned or artificial intelligence, and I keep getting put in either AUKUS or maritime industrial base, and I have to talk about kind of the mundane day-to-day maintenance grind here. So it's fun to do something a little bit exciting and forward-leaning, like unmanned. So to your specific question about submarine launched unmanned, let me first of all contrast submarine launched with the larger ship or shore launched. And the big difference is that with the larger vehicles that are ship or shore launched, they're just a lot bigger, right? I mean, space is at a premium. There is no more expensive piece of real estate on the planet than a square foot on a submarine. And so it's every inch is precious. So if I go off the submarine, I can just take advantage of some size. But that size brings challenges with it. So I can store more batteries so I can get more endurance, and I can put more payloads on it because I have more room. So that's the advantage. The disadvantage is now I have to replicate everything that the submarine is doing to get there, right? So I have to be able to navigate over long distances. I have to be able to survive in varying environments that I may not understand before I get into. So as I try to transit hundreds or thousands of miles like a submarine does, that's not really easy. Depending on what part of the water column you want to transit in, right? I mean, we don't operate submarines without checking in once a day to get a broadcast on what the intel picture and the environment is. So I got to have a way to replicate that. I also have to have a way to communicate. So I have to be able to command and control these very large vehicles. So all those things have to be built in, and none of them are easy, to be able to do. But it's the right thing to do to try to get after that. And I certainly think if we take, a rigorous stepped approach to chipping away, first chip away at just get from point A to point B, then chip away to get a little further, then add a payload, then add some navigation, then add some command and control, and move those things along. I certainly think that there's a bright future for unmanned that we're all committed to, because it's the right thing to do to be able to expand our capability and remove risk from our manned platforms, and do so at a lower cost to the American taxpayer. So now that's kind of the large. Now let me tell you, what is the advantage of a submarine launch? Well, in the submarine launched, I will trade some of that payload and endurance. However, I will remove the need to get it there, because the submarine can essentially transit and get close to the area. The submarine can be providing the intel picture and the environmental picture to the vehicle. Because if you think about, let's look at the example of the weather. We can predict the next day or two's of weather pretty well. I mean, we've gotten pretty good at knowing what the temperature is going to be like tomorrow, but 2 weeks from now is significantly more difficult, right? So when you look at a submarine launched vehicle, we're looking at operating for say 1 to 3 days, on the far end. And one day, very confidently, I'd like to get a little further out from that, but very confidently, I can operate 24 hours. I can also use the inherent sensors on the submarine to predict the weather, the environment, the threat, the contact density for that next 24 hours. So I don't need to bake all that into the UUV. I can just, I can use the cruise sensors to do that. Then I can send the UUV off to do something that either is not worth the submarine doing, because it's very simple. So we about a decade ago came up with the term, dull, dirty, and dangerous, right? So it's these kind of mundane things, which might be a seabed survey. So say I want to go investigate something on the seabed and just send the vehicle out to just go back and forth, maybe searching for a mine, maybe investigating a U.S. or allied piece of critical infrastructure, just to see what it looks like and identify what the problem is. I can send the vehicle off to go do that. Then the submarine can go off and do something else for the next, 24 hours and come back and pick it up. So that is a huge advantage of these onboard. And what I look at the possibilities to how these unmanned vehicles can help us is really endless. And I would include both, pure unmanned and even remotely operated, where I maybe have a tether and I can pull information in real time back to the submarine. So I don't have to recover the vehicle and wait to look at the data. I can just see it in real time and put a human in the loop. Now, ultimately, we'd like to use some artificial intelligence and machine learning in the future to offload some of that as well. But that's, again, we're going to take this one step at a time to get out there and operate. But I think we could use these vehicles for just general husbandry, to go look at the submarine hull, to test our sound signature. I could use it if I didn't want to go to periscope depth. Come up to the surface where an aircraft or surface ship might be able to see my periscope. I could send the vehicle up there instead to gain awareness. And then, the most obvious use of an unmanned vehicle is, a submarine has certain areas it just can't go. So it's no secret, the bottom of the submarine to the top of the sail is 50 feet. So let's just start there. I can't go any shallower than 50 feet with the submarine. And we actually back that off a little bit further. But now that area, if I want to get somewhere, the unmanned underwater vehicle can get there. So I'm opening up access, right? So if I want to go drive into a harbor, that vehicle might be able to do it. Similarly, there's a certain depth limit, right? The hull can only take so much pressure, and we design them for certain depths. So if I want to get really, really deep, like down to the ocean floor at full ocean depth, which is about 6,000 meters or 20,000 feet deep, I would have to do that with an unmanned vehicle. So if I want to go explore the deep ocean depth, so that's a whole other section of the water column that is not open to a submarine. That now, if I have that capability on board, the submarine captain can make the decision to go down and access that area. So it opens up a whole bunch of advantage for us. And then any payload you could put on there, the opportunities are really endless to how you can now expand the capability of the individual submarine. So a submarine, costs, upwards of $3 billion. A single, medium-sized torpedo tube launched unmanned underwater vehicle is, on the order of, say, $3 to $5 million, depending on how much capability you put into it. And so I can now, for that price, multiply the capability of that $3 billion submarine without taking risk to the crew, right? Without taking, risk to the vehicle, to the capability of the submarine itself, for a much lower cost. So, I can offload all that, yet get more capability out of the submarine. And I don't need to access the submarine to build that capability in. So I can go let the scientists in the lab work on the payload, right? And then I just load the vehicle on at, really very little impact to the crew. Whereas if I want to bake that into the submarine, I have to worry about making sure it meets all the compliance rules. I have to put people on board. I have to take power down so that I can get the installation done. So there's just a ton of opportunity in payloads and sensors once I have that capability on our submarines. So I'll pause there and see if any other panelists want to comment.
Yeah, thank you, Admiral, very much. That was a great viewpoint on the role of these vehicles and the role of UUVs in general in the future of undersea warfare. So, Dwayne, for one of the challenges in terms of fielding a sub-launched vehicle is just the whole launch and recovery process, and obviously you guys have put a lot of work into that, and you're looking at multiple size vehicles as well. So. In your efforts to develop these vehicles, what are some of the challenges in terms of fielding something that can be launched and recovered or controlled or managed by the host submarine? And how do you try to get to the admiral's point of giving him more time away from the host platform to maximize the utility or the duration over which you can operate these systems?
Yeah. Thanks for the question, Brian, and thanks to you and the Hudson Institute for hosting, and Admiral Goucher to be here on the panel as well. It's great to hear directly from the Admiral on what they're doing with the vehicles. So, I mean, it started off with your question about the submarine launched and recovery. So we've been launching and recovering UUVs from submarines for a little over 10 years now. I mean, initially we were doing it out of the dry deck shelters, and that has its constraints. And then there was some efforts where we were launching out of the torpedo tubes and swing back into dry deck shelters or being recovered by other platforms. But now, we're finally getting to that point where we're actually doing the torpedo tube launch and recovery. And I would be, we've done a lot on developing that technology and that capability. I would be remiss if I didn't also mention, our partners at Woods Hole Oceanographic Institution, who, really developed along with the Navy, the yellow moray technology that we're now taking and bringing into our vehicles and starting to upgrade older vehicles to have that capability. But that's really, to me in this area is a game-changing capability to be able to, launch out, go out, do a full mission. As the Admiral mentioned, 1, 2, 3 days. We continue to push that endurance, and I can talk about that a little bit here in a minute. But then, come back and rendezvous and recover. And I think that the other important part of that integration that sometimes is overlooked is really once you're integrated, we're integrated, into the combat system of the submarine. We're integrated into the communications of the submarine. So it's not just about the ability to come in and out, but it's really the ability to be interoperable with that submarine, and that opens up a whole host of capabilities. So we can go out and we can do a completely autonomous mission. The vehicles do not need a human in the loop. They can operate for multiple days on their own, but they can also operate in conjunction then with the submarine and do man-machined teaming, which brings a lot more use cases to the table. And then just thinking about where we're at with the technology and what we're doing and how we're trying to make them better, and where we're at now and what we think the future looks like. So I think for those of us in industry that are designing and building the systems, what we need to do is make sure that they're adaptable for future missions. So, we concentrate on all of our current generation vehicles, the ones we're building right now, and in particular for this applications, it's either the REMA 600 or the next generation REMA 620. And so we focus all of our new generation designs to be modular and open architecture. So modular meaning we can swap out payloads, we can swap out energy sections, we can swap out propulsion. Each piece is essentially independent of the other. It allows us a lot of things. We can bring more payloads. It eases maintenance. It also opens up the aperture of what we can do with the vehicles. And the second part of that is open architecture. And that open architecture extends from both the mechanical, the electrical interfaces, the communications interfaces, and the software interfaces. So that allows, not just the builder of the vehicle, but government and academia and other industry to create payloads for those vehicles as well. And so that's a huge capability. Essentially, we want to build a really robust platform. Oftentimes, we refer to that as as the truck that is going to carry these payloads. But that opens up missions around reconnaissance, mine countermeasures, seabed subsea warfare. We can tow acoustic sensors. So almost anything that you can imagine, we can probably get onto the vehicles. And then, as the Admiral mentioned, there's probably no more expensive space than a square foot on a submarine. So we want to maximize the capability of those vehicles that are being carried on the submarine. We know that there's limited space. It's competing with weapon systems. So we want that one UUV to be able to perform multiple missions. We talk about that a lot. One vehicle, many missions. So can we swap, payloads on board the host submarine? Can we change out energy sections? Can we reconfigure the vehicle? Can we repair it? Can we just pull a piece out and drop a new one in if something goes wrong? So make them as resilient as possible. And then, there was the Admiral touched a little bit there on, shore-based and ship-based, or, the submarine launched and what makes them different. And certainly as we're no longer constrained about coming into the torpedo tube, the vehicles can get larger. But I would offer one additional thing there, that even those UUVs that might be shore-launched or ship-launched, can still be made compatible with the submarine, can still share some of those interfaces that allow it to communicate, and still then open up the ability to rendezvous, to work with the submarine and perform missions for the submarine, even if they weren't organic to the submarine to begin with.
Thanks, Dwayne. I think those are really good points. We'll touch on a couple of those as we go through the rest of the conversation, in particular, this modularity and what the balance is between something that is resilient and robust and able to be repaired and modified in the field compared to something that's more expendable, and the trade-offs involved there, and maybe the role that outside UUVs might play because they can be more expendable. So Matt, I wanted to, since Dwayne brought up the challenges with C3 associated with UUVs, and that's one of your jobs is to figure out how to incorporate these in here. The kinds of sensors and communication systems and the autonomy software that you need, is that pretty much something that is about the same, whether it's a UUV that's operating off of a ship or shore versus one that's on the submarine, or do you need to bake a lot more into those off-board systems because they have to operate independently for a lot longer? And is that free up space or weight or computing power for the sub-launched ones that you can devote to other missions?
Sure, Brian, thanks, and appreciate the opportunity to be here with everybody, and it's a great question. So as Dwayne mentioned earlier, we try to also build our sensors to conform to both open hardware and software standards, because I think a big thing in the electronic sensing industry is that we're trying to eliminate vendor lock. So we build systems that really can integrate from that mechanical packaging and just slide right into a remus. But maybe you also want to have that working in concert with a UAV, and you can take that same sensor, same piece of software, and those two can be working in conjunction, right, that both follow those open standards. So I think that the big piece with openness is more so that the way that you communicate, the way that you control, and the way that you receive data is seamless across manned and unmanned platforms. And really what we're trying to do within my sensor team is enable those EW and other payloads to really persist and penetrate deeper into contested areas, which translates to improving our ability to execute those sensing missions, keeping both our operators and our really high valued assets, as the Admiral mentioned, the submarines, maybe farther stand off and in a safer place.
Thanks, Matt. And we'll come back to that in a second, because I wanted to ask Admiral Goucher. So you talked about a lot of the roles that sub-launch UUVs might play, and the relationship they have to off-board UUVs. Is one of the roles or one of the missions they might do essentially operations to protect the submarine? So doing things like counter-sensing missions, or trying to do things to hide the submarine, or to allow the submarine to operate somewhere else while it attracts attention to the decoy UUV. Are there ways that the UUV can be used both to augment what the submarine does, but also to protect the submarine?
Yeah, Brian, I think the possibilities are really endless. And, you heard, Dwayne and Matt talk about open architecture. So, my perfect world is, I want a lot of competition. I want all the most devious and dastardly brains the United States has to offer working hard to come up with dilemmas for our adversaries. And I certainly think, if I could launch 6, medium UUVs and make somebody think there's 6 submarines out there, whether that's because they're peeking up at the surface and they look like a periscope, or they're making a bunch of noise that sounds like a submarine below the waterline, or they're transmitting, automatic identification system, or some other electronic means that we think would be detected, then that's great, because that just adds to confusion and chaos, and then lets my primary platform go in and do its job with a higher probabilities of success, so more lethality and better survivability for the platform. And so, so I think all that is absolutely on the table, and we have to look at unmanned, with a multi-decade approach, right? So, right now our focus is on, hey, let's get the endurance right. And we've done a lot of work on battery technology over the last decade. And we've kind of got to the point where now we're there, which is a huge win for us. And now we're at can I get it in and out of the torpedo tube so I don't have to use divers? Like Dwayne had mentioned, a decade ago on North Dakota when we did one of our first missions. And so that's a huge deal. And those are hard problems that we've gotten after. So now we can start going after some of these more exquisite things. And I do think the possibilities are endless, as we look ahead. So I know I have to be a little careful to what we can and can't do, but I think that gives you a sense of where we're trying to go. And over time, I think we'll just get better and better.
Yeah, thanks, Admiral. And that makes a lot of sense. So one question that comes up in this context is, what's the trade-off in terms of offloading torpedoes or other weapons from the torpedo room to enable you to carry UUVs? And are you looking for ways to make that trade-off less, zero sum, if you will, by maybe the UUVs get launched from something else, like another countermeasures launcher or something? Are you looking for ways to either make that trade-off less necessary, or are you looking at ways to basically analyze the value of a UUV versus a torpedo in a different mission, in a particular mission?
Yeah, Brian. So I think it's all of the above. I mean, I think in a perfect world, if I was to kind of go make my, lightning bolts on PowerPoints, what I would like is I'd like a torpedo or a UUV that was small enough that I didn't have to take up a torpedo stow. And we actually have those today, and we've operated those off submarines where I can actually store them in a lockout trunk, or if they're modular, I can take them apart, and then I train my operators to put them together. I mean, so what you'd like to have is I'd like to just have like a suitcase with a whole bunch of payloads. I have a decoy payload. I have a weaponized payload. I have a electronic payload. I have a survey payload, and I just screw the parts together and I launch it out. Any way I can. I'd like to have disposable vehicles that I don't even have to recover, that I print 10,000 of and I just, put on board. But we're not there yet with that. But I certainly think that, thinking that way of, how do I move technology? I mean, you think about the computing power it took to land on the moon, we now fit in an iPhone. So let's make that assumption, and then let's keep driving one step at a time, towards that. And, as we methodically solve our problems. So that's really where we're at right now is where do I want to be in 20 years, and then back myself up to what do I have to do today? And, and realistically, everything for me is a football analogy. So I want to be careful that I'm not, running the flea flicker today, because really where we're at is, I want to line up. I don't want to be off sides, because whether I run the dive or the flea flicker, I still have to do that really, really well. So I want to be perfect at that. Then I want to snap the ball and not fumble it. Then I want to hand it off. And so that's the approach we're taking, but we keep that vision. And as technology accelerates and we're able to bring it on, then we're going to bring it on. But right now it's, hey, let's just get the vehicle in and out of the torpedo tube effectively. And then that opens everything else up for us.
Right.
That's to just kind of be quite honest of where we're at and where we're going.
Yeah, Admiral, that definitely makes sense as an approach, and definitely the progress has been there. So it's not like that is not resulting in wins. So that's been working. And so Dwayne, to the Admiral's point, we are kind of stepwise trying to improve the ability to take advantage of this technology. How is that? How fast do you think we're going to be able to get to the point where we can routinely have UUVs going in and out of the torpedo tubes? And how far do you think we are from this modular type of design where you don't have to stow something on a torpedo stow and I can store it somewhere else and relieve the impact on weapons capacity on the ship?
Yeah, so I'll answer the second part of your question first about where we are on the modularity, and I guess, and then where are we on not having to stow them on the torpedo tube. So I mean, there's a couple aspects right now. So I think that we're there on modularity. I mean, we can always improve that, but right now, as we build the vehicles and we design the vehicles, we can take out energy sections and we can replace them. It's really energy agnostic, so we can put a high density energy source into the vehicle, whether that's lithium-ion batteries or something else. We can put a propagation resistant battery in there. We can stack multiple battery modules together to get longer endurance. The propulsion and the navigation sections are completely independent, so it's reasonable to to put a high-speed tail on or or a different navigation section. Then the payloads, same thing. They can be wet or dry payloads that we put onto on the front or the back of the vehicle. So I think when we talk about then the capabilities, what can we do, in the torpedo room to save stows? It also starts to become a weight and handling issue, because a medium-sized vehicle is fairly large. So we can potentially change out modules. I believe that's very practical there in the torpedo room. But taking a medium class vehicle on and off and storing it somewhere else is probably not as realistic. But the same thing applies to the smaller vehicles. And the Admiral mentioned the small UUV. So we're building small UUVs right now at quantity for the Lionfish program. So in total we'll deliver over 100 small class UUVs this year. So in that case, we have the ability to both build at scale, we can have the ability to build less expensively, and those vehicles share the exact same modularity as a larger vehicle. So those could be stored somewhere else. They could be taken in and out of a lockout chamber. They could conceivably be taken into the torpedo room and launched and recovered out of torpedo tubes. Those are not things necessarily that we're doing today, but those are things that are very much within the realm of what is possible today. And so, but we'll continue to look at the capabilities, whether it's energy and intelligence in the vehicles that make them able to run longer and longer and more complex missions, make them more capable of man-machine teaming. And it gets, as we get down to follow on the football analogy, as we get the blocking and tackling down, we'll attack more complex missions. But even right now, we can do multi-domain missions. One of the payloads that we've developed, we actually use this, and this is again the ability to reuse what's on the submarine. We use the SLUAS, the program of record 3-inch canister that's on board the submarine now, that launches an unmanned aerial vehicle. We have that as a payload on our medium class vehicle, so we can launch many of those out of the UUV, just as an example of what's where we're going and what is possible. So now you can imagine we can launch a UUV that goes out and gets away from the submarine, launches the same UAV that the submarine would launch out of its 3-inch launcher, but away to not give away the position and provide that same capability. And you could expand that one step further. That same unmanned aerial vehicle could also become a loitering munition that could be launched off board from the submarine. So really looking at how we expand the reach of the submarine, whether we do that through things like unmanned aerial vehicles, or we do that through man-machine teaming, or we do that through sensors, whether passive or active, and running, ASW or ASW pickets for a submarine. I think those are some of the things that, we would look at pushing the technology for the future.
Thanks, Dwayne. And so to that point, Matt, one of the areas that you're looking at is electronic warfare. So using submarines to do electronic surveillance, generate electronic effects, even RF-enabled cyber effects against enemy forces. How practical is that to do from a UUV? How do you operationalize that mission out of a UUV that the submarine might launch?
Sure. Yeah, I think it's extremely practical. If you take the mission sets that we currently support now, kind of break them into two buckets. One would be passive listening, where we're not transmitting, and then you have the other side of the house, active, where you are transmitting. So on the passive side of the house, we kind of talked about taking a UUV, having it sail into maybe a shallow harbor. We could have something like a REMIS surface and then perform a series of passive missions. We can see, from an RF perspective, what do we see is from that RF picture in the harbor? Are there threat radars? Are there threat communication systems? Things of that nature that we want to maybe just monitor over time. Maybe we want to geolocate them and then relay that information back to the submarine. But I'm doing that via a forward unmanned platform, right, that can get into areas where I typically can't get with that larger platform. And then you can also flip that. So we've designed all of these HII built payloads to be both passive and active, so that I can retask that same piece of hardware to then go active, right? Maybe I have another mission I'm performing in parallel. I want to go and execute that decoy mission to maybe add some confusion, or maybe I want to go and do a counter radar type mission, something like that. The types of sensors that we're building allow both that flexibility of passive and active within the same payload, integrated into a platform like a REMIS. And then if you that's kind of current state. If you look into the future, what we're really doing is kind of that really tactical edge, multifunction RF with security built in. So our team is currently designing RF ASICs that take processing, RF sampling, and security and putting it into a single package. So what that enables is really that reduction of size, weight, power, and cost, all of which are extremely important when we're talking about uncrewed systems that at some point they may be small enough and cheap enough where we don't care if we lose them, right? So, but taking that edge processing, we can integrate AI, we can integrate that right, sensor processing at the edge on something that's disposable long term. And those are the types of electronics that we're building and fielding right now.
And so, Matt, I guess in that case, if you're doing that kind of mission, it would be able to communicate back to the MOC, the Maritime Operations Center, or I guess even to the submarine via RF. So you'd be able to, it wouldn't have to necessarily return to the submarine. It could send what it's finding maybe directly to receiver via satellite communications, right?
Absolutely. And the way that we try to employ these sensors is putting the processing at the sensor as well. So you're not streaming back that raw data, which, right, that may be a really high bandwidth comms link that somebody could see in the RF domain. We're doing that edge processing and more sending back the answers. And that kind of gets back to the open architecture discussion we were having earlier. So taking the Cricket, which is our product as an example, right? We can integrate those comms back and have it relay through the platform, or you could have a separate software-defined radio link that communicates with another platform as well that's customized. So really that flexibility as you employ these types of sensors at the edge.
Thanks, Matt. So I want to turn to some of the questions we're getting from our media partners that are out there, or maybe the media people that are listening in. So I'll start with Dexter Filkins of the New Yorker. Had a couple of questions, mostly for Admiral Goucher. So I want to direct those to you, Admiral. So the first thing that we're looking at, I guess the questions revolve around how many uncrewed systems or uncrewed undersea systems is the Navy currently deploying? I think in the context mostly of submarine related operations as opposed to like mine warfare, I assume. And then when do you think these systems might be made available to allies? Is there any effort to, maybe share them via AUKUS or via other technology cooperation types of arrangements? So how many of these systems are out operating today, and then are there potential opportunities to share them with allies?
Okay, well, thanks for that question. So today, USS Delaware is deployed to the EUCOM Theater of Operations with a Remus 600 yellow moray system. She has operated it in a Norwegian fjord for some, testing and evaluation, and being very transparent. We had some success and some not so much success, otherwise known as failure. But we've taken the vehicle back. We've learned lessons, right? And we're taking, I'll call a SpaceX approach to, hey, get it out there and operate. Because what we find is we learn a lot more when we get it in the crew's hands. So we've made some software adjustments, and we're going to put it back out in Europe, and we're going to reload it in April, and we're going to go back and do it again on that deployed submarine. Then our plan going forward is to maintain a UUV deployed somewhere in the world all the time. And so even for vehicles that, or for submarines that don't have torpedo tube launch and recovery, we're taking smaller vehicles, we're putting them on board, and the orders are surface the submarine and throw them over the side. But darn it, we're going to operate UUVs. And so we're working through that now. And I think Newport News is our next one that we'll deploy, and she'll have a smaller vehicle. And then there's a couple boats in the Pacific that we're going to get the next version of the yellow moray on. And then finally, we also have a remotely operated vehicle that remains tethered. It's a program of record called Tetra, and we're going to deploy that here at the end of 2025 to the EUCOM Theater of Operations and to the Indo-PACOM Theater of Operations. So we'll have those deployed at the same time. So that's kind of getting to all of our remotely operated or autonomous systems. Now to the allies, we have a very strong relationship with the UK and Australia on unmanned, and we're teaming, with similar systems. As a matter of fact, we've given, some of our canisters to the UK so they could practice off their Astute class really late in 2024. We operate together in integrated battle problem 25.1, which had an element off the coast of Norfolk and an element off the coast of San Diego, where we executed some defense of critical undersea infrastructure exercises. And that was a complete US or Australia and Royal Navy participating in that had unmanned vehicles and remotely operated vehicles in it. And then pretty much every one of our partners, throughout NATO and in the Indo-Pacific has an unmanned underwater vehicle program. The Japanese have a fairly well-developed program. I already talked about Australia. They also have a large program called Ghost Shark, which is actually pretty impressive, and they've brought that to bear in a couple years. The Swedes, the Norwegians, the Italians, the Portuguese, they all have different vehicles they're operating. And we're planning, kind of in my NATO role as Allied Submarine Command, we're working with our ComSub NATO partners to host or to sponsor unmanned vehicle exercise in September in Portugal called Dynamic Messenger, where we will test our ability to defend underwater infrastructure. So, and there's a lot of energy. The allies recognize the value of it, and they're certainly all in on it as well. So there's a ton of opportunity to learn from each other there as well.
Thanks, Admiral. I think you bring up a great point about the defense of undersea infrastructure. Clearly, Russia and China have made that a target already for their gray zone operations. And so are you finding that those exercises demonstrate that UUVs can be pretty effective in that mission?
I think really it's a combination of UUVs and remotely operated vehicles, or ROVs, is really the tool set you need to bring it to bear, and then the weapon if you really want to defend, once you're sure they're down there. And so you got to put all three of those together. And when we ran integrated battle problem 25.1, we did just that.
So you need a kill chain, basically. You gotta set that up. And I guess one last follow-up question. So in terms of weapons, are we able to use torpedoes against these, or do we use mine countermeasure type weapons?
So there's a bunch of different options with weapons. Some of that is still very developmental, but I think certainly it'd be hard to use a torpedo. You'd have to reprogram it, but that's certainly something we're looking at. You could use a remotely operated vehicle to just go down and to interdict it. You could use other things to make the environment difficult, or you could just go find the launch platform. So I certainly, if a surface ship was using it, a Mark 48 would work just fine against that, and you'd solve the problem a different way. So.
Yeah, good point. Another group of questions relate to just the challenges of operating on and off the submarine. So, Dwayne, and then for Admiral Goucher, I think one question is, or the way to frame that question is, there's obviously it's a challenge to have these on the submarine. It takes up weapons space potentially. You have to deploy them and recover them. There's mechanical requirements for that. So what's the benefit of going through all that effort rather than having something just get launched from shore or from a ship? It seems like one of the things you're describing is you can offload a lot of the difficult parts of having an autonomous system onto the submarine. And so the autonomous system doesn't need to be nearly as sophisticated as it might otherwise need to be. Is that what you're able to do, is this kind of trade-off to get these in the water faster? Or are there other benefits to going through the hassle of submarine launch and recovery? So Dwayne and then Admiral.
Yeah. So, I'll talk about from my aspect from industry. To me, it's absolutely worth the challenge, and we're getting better and better at that, and we're refining the technology to make that more and more reliable. And if you look at organically employing a UUV on a submarine and the advantages that it brings, one of the great strengths, and we mentioned before, of robotic and autonomous systems is that their ability to go off and do those dull, dirty, dangerous missions. They can work in contested environments. They can help clear mines, decoying, and we talked about delivering effects. And to be able to do that, to be brought into an area covertly with a submarine, and expand the reach of the submarine, one or more vehicles going out and being an offboard sensor network for the submarines. That's, you could conceive other ways that they could be dropped off and brought to bear, but in the time of a conflict, we may not be able to get those other platforms into those areas, and submarines are probably the only way that we're going to penetrate those areas. So having that capability is game changing. And I don't think it needs to be, all or nothing or one or the other. It's some combination, because you can also imagine where we can, in some areas of the world, we could forward deploy a lot of UUVs. So we don't have to bring them all in submarines, and they could rendezvous because of the interoperability. They could come back in. They could be launched and recovered. So there's a lot of ways to do that. But, it's still, to me, a core capability and a really important capability to be able to organically carry UUVs and really be a partner in that subsea mission between the manned and unmanned platform. Because I think we all know with the price of a submarine, there are missions that multi-billion-dollar platform with 120 really intelligent people operating on it can only do. But there are a lot of other missions that we can do with unmanned systems and UUVs, and so being able to deploy them from a submarine, to me, is a extremely important capability.
Yeah. Hey, Brian, I agree with Dwayne. So first of all, on the why a submarine, I sit through a lot of ConOps briefs, and we talk about unmanned systems, and then someone will raise their hand and say, well, how do we get them there? And it gets really silent. So the ability to access contested areas is the value of being able to put unmanned systems on a submarine and make that submarine more valuable because you increase its capability. But looking more broadly, our strategy as a Navy is to have a family of systems. So think about, at home, right? You have a toolbox and you have a bunch of different screwdrivers. right? You got the really fine one that you need to kind of deal with your hard drive and everything. And then you got the big one when you're outside, to be able to get a little bit more torque. And then you also have kind of like the ROV version, which is the electric version, right? That brings you a bunch of different capability. Well, our approach with unmanned is similar, right? So it's the right vehicle for the right mission, right? In order to offload what a platform does. So there is absolutely positively a role for large and extra large, right? And frankly, I talked about getting really deep down to 6,000 meters. Well, that's wicked hard with a smaller vehicle, right? And it's wicked expensive to build, titanium hulls or everything else. But we already today, industry has built large vehicles that get down there. So, so I can get down there already. And if you look at the challenges of unmanned, if I kind of were to jot them down real quick, which I did, I would say operating up at the surface is a challenge because I have to worry about running into other ships. I have to worry about nets. I have to worry about things like kelp, right? And so for a small or medium, I'm not as worried about that because if I run it over with a ship, you're not even going to know the difference. I have this big extra large thing and I run into a ship with it. Now I have a collision at sea. That's something I have to worry about. So there's technology I have to think about, but there's trade-offs there. Navigation, I talked about that already. Long distance navigation is a challenge, particularly if I take GPS away or I'm not confident in GPS. And even then, I still have to get to the surface or close to the surface to get a fix. Endurance is a challenge. We talked about that. So extra large and large, I can put a lot of batteries on it. So I gain that endurance. Submarine launched, I don't get as much endurance. Torpedo tube launch and recovery, getting it in and out of that, 21-inch hole. Well, that's a challenge, right? If I just go in and out of a surface ship with a launch and recovery system, I take that away. So, each case it's a trade-off. Command and control. Am I nearby tending it with acoustic communications or short range line of sight, or do I have to reach back via a satellite? Weather. Do I have the ability to predict weather over long periods of time and changing ocean environments that just I know up front, the temperature change and the salinity is going to be different, which changes my buoyancy. Those are challenges of large and extra large going long distances, as opposed to a submarine with a nuclear reactor and deciders on board who can just overcome that with speed and power. And then we talked about access already. So all those things come into play. And then I say, okay, what is the most efficient and most effective tool for the mission I'm given? And I think I need the range from small all the way up to extra large to truly have the hybrid fleet that we're driving for in order to be the most effective Navy for the American people. Over.
Thanks, Admiral. That makes a lot of sense, and that really highlights some of the challenges we've been talking about here. So one thing I wanted to sort of bear down on, and this gets to something Matt does. So navigation, Matt, how do we ensure that if a vehicle is going to operate for a few days by itself away from the submarine, how good does it need to have in terms of an inertial navigator? Does it need to have, I guess?
Sure. I mean, I think that I'd like Dwayne to weigh in on this one as well. I think extremely precise, but there's other things we can do as well when we're at the surface, particularly in a denied environment. We have other payloads that we're building that will allow us to persist in GPS denied environments, where we have phased arrays that can identify interference sources, right, and then mitigate those digitally. So that when we're at the surface, we know where we are, and we also know where we're going. And then I'll turn the INU question over to Dwayne to discuss that a little bit more.
Yeah, I can pick up there. So, I mean, it is definitely one of those it depends kind of answers. So, I mean, underwater navigation is a challenge. There are ways, with inertial navigation systems, we can go long distances without an outside fix, but the error grows over time. So it really comes down to what does a mission require? How accurate are you going to have to be? And that's gonna also govern the size of the vehicle, because there's two trade-offs. One, the more accurate the inertial navigation system is, or the navigation system in general, the more expensive it's going to be. and it's also the larger it's going to be. So in a small vehicle, we're going to run into limits with technology of how good we can make the inertial navigation system. And then as we get to the medium class vehicles, really going to come down to a cost and capability trade-off. So if you want really accurate navigation, that exists, and we're gonna pay some cost and size penalty for that. But there are other missions where you don't need that accuracy, or you might be able to communicate with another platform to update your position. We could even use the host submarine as a way to position. So there's a lot of ways around that, and it just comes back to the trade-offs of getting, so a little bit to what the Admiral was talking about earlier, getting the right platform, the right vehicle for the right mission. We can solve all those problems, somewhere in that trade-off box.
And so thanks, Dwayne. And so this gets to another question that Sam Legrone had is, it looks like we've made a lot of progress in the Navy on fielding UUVs. And it seems like maybe some of the reasons we've been able to move faster is in part because we can launch them from submarines in this case. It offloads some of the technology challenges to the submarine and makes it easier to get a operationally useful vehicle out into the field and faster than we would otherwise. Because if you look at other parts of the uncrewed part of the uncrewed portfolio in the Navy, they're not progressing as quickly, and they're having some developmental challenges. So Admiral Goucher, do you see the ability of sub-launch UUVs to offload some of this technology challenge to the submarine as one benefit in terms of getting them out there faster, so we can go through that stepwise process of fielding, or do you think that this is just a function of we've had more experience with this technology and it's just going faster as a result?
Yeah, I think it's probably a little bit more of the latter. I mean, I think that we're making good progress across a number of areas, and we're working, cross domain. I mean, clearly, naval aviation has really led unmanned. Now, there's a significantly different challenge underwater than in the air, and then the surface kind of bridges both because they have the benefit of comms and navigation until it goes away, and then they deal with all the same problems we deal with. And so I think there's been a pretty good crosstalk there, and I think you're starting to see that now in some of the initiatives that are out there. So I think it's a little bit of both. I wouldn't say that. I mean, we have our challenges, and certainly naval special warfare and explosive ordnance disposal. They've really got a lot of experience, as does Naval Oceanographic Office. A ton of experience with unmanned. Now they operate from a surface ship, and it's typically for a specific mission, but they've moved the needle on those things. So there is a lot of value you don't always hear about in unmanned. It's when you start getting into warfighting applications, denied areas, lethality, those sorts of things. Now you're really kind of getting to a whole different level, and so we're trying to leverage what they've done and move that forward. And I think maybe because we have the access with a submarine and we're able to do some things far forward, you're seeing a little bit more of our operations start to bear a little bit of fruit.
Right. Yes, that makes sense. And so would you say that it seems like a lot of the missions we're thinking about for sub-launch UUVs support offensive operations? I guess certainly there's some intelligence gathering you can do, but it seems like a lot of these are oriented around taking advantage of the access to threaten an opponent in a way that might deter aggression, more so than what you get out of a long endurance UAV that does surveillance, or a mine warfare UUV. Do you see that the role of the sub-launch UUV is being a little bit more offensively oriented in general compared to maybe what we've done thus far with the uncrewed systems in the Navy?
Yeah, I think that's a fair characterization because I mean, the value of a submarine is all about access, right? We can go where we want, when we want, and fight on our terms. And the unmanned capability just adds to that for the submarine. And I mean, to give you kind of a simple example, right? So if there's a chart and it has a shallow area, but it's, maybe it was, surveyed by Captain Cook, with a rope and a rock, and we question it and we say, hey, that shouldn't be there. Well, I have to assume it's there, but that's all maneuver space that I would like to have available if I had to go fight, if I had to conduct offensive operations there. So if I had the ability to go into that area that may not be easy for a surface ship to get to and launch a UUV to survey it. And even if it couldn't get me a chart quality fix, if it could at least say, hey, I know there's at least 500 feet of water there. Well, that's 500 feet of water I might have had to have avoided. So now if I have to run across that to avoid a weapon, or I have to run across it to close an enemy contact that I want to shoot at, that's now available to me. So, just kind of keeping a simple example of how I can open maneuver space for my submarine for warfighting advantage is a great application of where we might want to use a UUV and a simple safety of navigation to generate offensive capability.
Right. Yeah, that's what I was thinking, is it's enabler of the offensive capability. Well, we are about out of time, and so I want to thank you, gentlemen, for participating in today's panel and talking about the future of autonomous warfare, and particularly the future of autonomous undersea warfare. And so we've been talking with Admiral Rob Goucher, the commander of U.S. submarine forces, Atlantic, as well as submarine forces in general, and also commander of NATO undersea forces. Also, Dwayne Fotheringham, president of HII's uncrewed systems division, and also Matt Britton, who's the director of C5ISR at HII. So, gentlemen, thank you very much for your time today, and I really appreciate you being with us.